Hi everyone, this is ExRS and welcome to my YouTube channel. For today's tutorial video, we are going to discuss one of the probability topics, yung tinatawag natin na permutation. So, without more ado, let's begin this tutorial video. Permutations, it is an ordered sequence of the elements. So, it is an arrangement of objects with regards to order. When we're talking about permutations, palagi natin kailangan tandaan na yung kanyang pagkakasunod-sunod ay important. So, for example, one main example na palagi natin na-encounter is yung phone number, mobile number natin. Bakit? Kasi, yung phone number natin is an 11-digit permutation. So, bawat digit nun is drawn from 0 to 9 integers. And, the way siya pagkakasunod-sunod, of course, is important kasi yun yung personal number mo. Parang ganun. And another example na palagi natin na-encounter is yung ating password sa phones or passcodes. Kasi, mga 4-digit na yan, that's a 4-digit permutation ulit. Kapag hindi mo nailagay ng tama ng pagkakasunod-sunod yung kanang digit, hindi mo mabubuksan yung laptops, phones, or other gadgets mo. So, that's example of permutation. So, example number 1, we are given a sample space of A, B, and C. So, ayan, ito yung ating mga elements. We have A, B, and C. Kung alamin natin yung permutation gamit yung sample space na to, so, ayan yan, yung kanyang sequence ng elements na magkakasunod-sunod niya. We have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Ibig sabihin, meron tayong 6 na mabubuong permutations out of the sample space natin na A, B, C. So, the answer, for example, number 1 ay 6 permutations. For permutations, meron tayong iba't ibang types and iba't ibang formula sa gagamitin depende sa situation. For permutation, madalas nating ma-encounter sa formulas natin is yung tinatawag natin na factorial. So, the symbol, yung exclamation point na yan, the symbol na ganyan is used to denote as the factorials. The value of the factorial of a number is obtained by multiplying all the integers from that number to 1. So, factorial of 0 is always 1. This is our factorial. Kapag nakakita tayo ng any number, for example, we are going to solve the factorial of 6 or 6 factorial. So, ilagay natin ito, 6, 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4, 6 minus 5. Hindi na natin pwedeng ilagay na 6 minus 6. Kasi, magsi-0 na yun. So, hanggang dyan na lang. So, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. Kasi pag nilagay natin yung 0 na yan, lahat yan magsi-0 na. So, yun lang, hanggang dito lang tayo. So, 6 factorial now is equal to 720. So, halimbawa, ganyan ang pag-solve ng factorial. So, yun lang yung dapat natin tandaan when it comes to factorial. Next, we have different types of permutation. Number 1, the number of arrangements of distinct objects taken all at a time or yung tinatawag natin as the linear permutation. For linear permutation, of course, meron tayong formula na, ayan, n factorial lang simply. So, we have npn. Yung npn na yan, pwede nating i-direct through calculator, through scientific calculator yung pag-solve ng linear permutation. Pwedeng n factorial or pwedeng ilagay natin as npn. Okay? Example number 2 for linear permutation. How many arrangements can 4 students be seated in a row of 4 chairs? So, we have linear permutations. Meron tayong 4 na upuan at 4 na estudyante. So, of course, with regards to order, kasi nasa permutation nga tayo. Using the formula, para malaman natin kung ilang arrangements ang magagawa natin dun sa students na 4 na ilalagay natin or iupo natin sa 4 chairs. So, we have npn is equal to n factorial. Ang n natin is 4. Taken all at a time, we have 4p4 is equal to 4 factorial. So, solving, we have 4 times 4 minus 1, 4 minus 2, times 4 minus 3. Hindi na pwedeng ilagay na 4 minus 4 kasi 0 na yun. Hanggang dyan lang siya. So, this is 4 times 3 times 2 times 1. Pwede rin kung i-direct natin as 4 factorial sa scientific calculator natin, makukuha na agad natin yung sagot. But this is just a formal solution. 4 factorial is equal to 24 ways or arrangements. So, this is for example number 2. So, ganyan lang yung linear permutation. Taken all at a time. Yun ang note natin lagi. Taken all at a time for linear permutation. Next type, we have number 2. The number of arrangements of distinct objects taken are objects at a time. So, yung first type natin kanina, taken all at a time. Dito naman, may portion lang tayo na kukunin. And tinatawag natin to as the permutation of subsets. Kasi yung linear permutation kanina, all sets yun. Taken all sets at a time. For type 2, permutation of subsets. Kukuha lang tayo ng portions. And for permutation of subsets, meron tayong formula na NPR is equal to n factorial over n minus r quantity factorial. So, yung n natin, yung total ng objects, and yung r natin is yung subset or yung portion lang na kinuha mo dun sa total objects natin. So, example, number 3, para mas maintindihan. A field has 10 different location points in which a flag can be placed. If 6 different colored flags are to be placed on the field, how many different ways are possible? So, para mas madali, ang gawin natin, ilagay muna natin yung given. Ano ba yung n at saka ano ba yung r? Ang n natin is, eto, 10 daw. 10 different location. And then, sa 10 different locations din, maglalagay tayo ng 6 lang na flag. Kasi kung 10 flag din yan, linear permutation lang ang gagawin natin. Simply, 10 factorial lang. Pero dahil 10 bakanting location ilalagyan, tapos 6 lang yung ilalagay mo, maraming possible na arrangements ang mangyayari. That's why we will use the formula. Ang R natin is 6. So, substituting, we have 10 P6. Pwede nating i-direct through calculator or we will use this formula. N factorial na 10 factorial over 10 minus 6 quantity factorial. The value now is 151,200 ways or arrangements na pwedeng ilagay yung 6 na different colored flags dun sa location natin na 10. Example number 4. For permutation of subsets pa din tayo. 4 awards will be given to an engineering class of 25 students. So, meron tayong 25 students. Pero, ang bibigyan lang natin na award is 4. Random. If each student can receive at most 1 award, how many possible selections are there? N natin is 25. R is 4. So, we just use the formula. This is 25 P4 or 25 factorial over 25 minus 4 factorial. So, ganyan lang gagawin natin for permutation of subsets. And by calculating, 303,600 ways or selections. Next, we have example number 5. 2 officers, president and vice president, are to be chosen from a class consisting of 26 students. This is students. How many different choices of officers are possible? Again, lagay muna natin, we have N is equal to 26 students and dalawang officers na pagpipilian sa kanila, we have 2. R is equal to 2. So, lagay natin sa formula, we have 26P2 is equal to 26 factorial over 26 minus 2 quantity factorial, and calculating, malalaman na agad natin yung value, 650 choices or ways. For example number 6. From example number 5, example kanina na dalawa daw, president and vice president ay kukunin sa class of 26 students. So, yan, 26 students. The question, from example number 5, how many different choices of officers are possible if student A will serve only if he is the president? Si student A ngayon merong kondisyon. Sabi ni student A, papayag daw siya na maging officer kapag president lang siya. So, yun lang. Ang gusto ni A, president siya. In this problem, we will consider two situations. So, unang situation, this, halimbawa, this situation A. Sa situation A natin, papayag yung buong klase of 25 students na i-elect si student A as the president. So, lagay natin. A is selected as the president. So, ibig sabihin, mababawasan dito tayo ng selection for vice president na lang tayo mamimili. And ngayon, ibig sabihin na si student A na president, meron pa tayong 25 students para sa vice president. So, hindi na natin kailangan ng formula doon ng permutation of subsets kasi isa na lang na may pipiliin out of 25 students. So, meron na lang tayong 25 ways. And yung 25 ways na yan ay galing sa 25 outcomes or 25 selections for the vice president. So, ito na yung ating una. Pero, yan yung situation na kapag si A na agad yung president natin. Pero, halimbawa, pangalawang situation, dahil demanding si student A, nagalit sa kanya ngayon yung buong klase, tinanggal na siya sa choices. Ibig sabihin, 25 na lang yung pamimilian ng president and vice president. Dahil nga, demanding si A, gusto niya, magsiserve lang siya bilang president, eh ayaw na buong klase, tinanggal na siya. So, officers are selected from the remaining 25. 25 without student A. So, paano natin malalaman kung ilang ways yan? Ang gawin na natin, ang N natin ngayon ay 25 na lang dahil wala na si A. And ang R natin is 2. Yung nasa choices ay yung 2, yung ating officers. So, gawin natin yung permutation of subsets. We have 25P2 or 25 factorial over 25 minus 2 quantity factorial. Ang value nan ngayon ay 600 ways. And dahil sa problem natin, for example number 6, ang sabi niya, how many different choices of officers are possible if student A will serve only if he is the president? Dalawang situation natin and we have to consider each situations. So, letter A at saka letter B, ang gagawin natin, pagsasamahin natin kasi sila ay total number of choices and yun yung magiging answer natin for example number 6. For total number of choices is equal to 600, yung wala si A, yung tinanggal siya, plus 25 na si A yung magiging president. So, ang sagot natin is 625 ways or selection. So, that's example number 6. Example number 7. From example number 5 ulit, yung 2 officers from 26 students. How many different choices of representatives are possible if student A and student B will serve together or not at all? So, meron na namang condition. This time, dalawang students. Si student A at si student B, ang gusto nila, magsiserve sila as president and vice president. Kaya lang, kung hindi sila pipiliin, hindi na lang sila magsiserve at all. So, dalawang situation ulit yan. For situation A, i-elect si A at saka si B as President and Vice President. A and B elected as President and Vice President. For situation A, hindi natin ma-apply nito ng permutation of subsets kasi unang-una, wala tayong N at saka wala tayong R. So, si student A at saka B, dalawa, and then meron lang tayong dalawang position for officers. So, para mangyari dito is linear permutation lang. We have N na 2, si A and B, tsaka 2 din naman yung officers, 2 factorial lang mangyayari dito. 2 factorial is equal to simply 2 ways lang din siya. So, yan yung situation A. And may pangalawa pa tayong situation. For situation B, A and B will not serve at all. Dahil maarte sila, dahil demanding sila, tinanggal na sila ng klase or ayaw nilang sumali sa election. So, ang mangyayari dito, yung 26 students mo is babawasan natin ng dalawa, tatanggalin na natin si A at saka si B. So, matitira, we have 24 na lang for N. 24 and we still have 2 officers. Na yung officers na yun na dalawa, doon na lang natin kukunin sa remaining 24 students without A and B. So, this is 24P2 or 24 factorial over 24 minus 2 quantity factorial. Ang sagot dyan ay 552 ways. Pero, this is not the final answer yet. Kasi, for example number 7, we have to consider the 2 situations. So, ang gagawin natin, pagsasamahin lang natin is either situation A or situation B. So, pagsasamahin natin, total number of ways. We have 552 plus 2 is equal to 554 total number of ways. Example number 8. From example number 5 ulit, hindi pa tapos. So, how many different choices of representatives or officers na pinag-usapan dito are possible if student A and student B will not serve together? So, from example number 5, ang condition naman dito, ayaw magsama ni student A tsaka ni student B as vice or president. So, mangyayari dito, we have 3 situations here. Unang situation, kapag ang papayagan nila ay si A kasi ayaw nga magsama ni A tsaka ni B. Papayagan nila si A, wala si B. Pangalawang situation, papayagan nila si B, wala si A. Pangatlong situation, dahil demanding yung dalawa, madaming condition, tinanggal na lang silang dalawa. That's the third situation. For situation A, selections when A serves and not B. Yan. So, that's situation A. Ang mangyari dyan, so, ang mangyari dito sa situation A is more like a multiplication rule lang. Lagay natin, we have 2 times 24. Okay, paano ba naging 2 and 24 yan? Yun 2, kasi si A binigyan na ng privilege para mamili kung president or vice president siya. Ibig sabihin, meron siyang 2 choices. Ito yung for number of positions, A can take. Ngayon, dahil nakapili na siya, may matitira pang isa, yung isa na yun matitira ay pagpipilian na lang dun sa 24 na students. Kasi 25 na lang sila, si A may privilege na mamili ng sa dalawang position, and after ng dalawa, meron pang natitirang 24 para dun sa natitirang position na hindi pipiliin ni A. So, this 24 ay yung number of selections for VP. Kasi ang pipiliin of course ni A ay President. So, dito, ang magiging sagot ay 48 ways. Ayan. Next, for situation B naman. Sa situation B, baliktad naman sila. selections when B serves and not A. Yung A at saka B, parehong situation lang. Yun nga lang reverse A at saka si B. Ibig sabihin, parehong number of ways lang din tayo dito. So, this is 2 times 24 din. Ito yung 4B naman. And 24. This is 48 ways pa din. So, this is situation B na pinagbaliktad lang. Kasi unang-una, si B naman, pipili niya of course President. And yung hindi mapipili na Vice President, kukuha dun sa natitirang 24 pa na students kasi they are 25 in total, si B at saka in 24. Parang sa situation A. And for the last situation, dahil attitude si student A at saka si student B, nag-decide yung klase, tanggalin na lang sila. So, ang mangyayari dyan, A and B are not chosen. Tanggal na sila sa pagpipilian. So, directly, permutation of subsets formula na lang ang gagamitin natin dito. Ang N natin is, tinanggal yung dalawa, si A tsaka si B, 24 na lang. And same pa din na R, we have two officers. This is 24P2 is equal to 24 factorial over 24 minus 2 quantity factorial. This is now 552 ways. And of course, we always have to consider all the situations sa isang problem, especially in permutations. So, ang gagawin natin dyan, kumbaga, the situation kasi it could be A, B, or C. So, pag-aadin natin silang lahat. Total number of ways is equal to 552 plus 48 plus 48 is equal to 648 ways. So, that's example number 8. In probability, take note, meron tayong palaging tinatandaan na keyword na and at saka yung or. So, yung and at saka or na yan, mahalaga yan, especially in solving probabilities. Sa example 6, 7 at saka dito sa 8 natin, palagi natin, kasi may mga ibang, marami tayong situations eh. Sa 6 at 7, dalawang situations. For example, number 8, tatlong situations. Lagi natin kinoconsider, sabi, A or B or C. Tatandaan natin kapag or yung kinoconsider natin na situations, A or B or C na selection, pag-aadin lang natin sila lagi. Kapag ka and naman, halimbawa, sabi dito, A and B and C na situations ang kailangan natin consider. Pag and ang sinabi, ang gagawin natin is multiply. So, for example, number 8, 7, at saka 6, ang sabi, A or B or C. So, kaya ang ginagawa natin kanina pa is pinag-add natin yung number of ways nila kasi A or B or C. Ngayon, kapag ang naging situation naman is A and B and C, multiply yun. So, itong and at saka or na principle na to, mas madidiscuss pa natin ito sa probability topic na natin mismo. Third type of permutation is the number of permutation of n objects that are alike, or yung tinatawag natin as the permutation of similar objects. So, we have the formula. P is equal to n factorial over n1 factorial, n2 factorial, hanggang nr factorial. So, ang concept lang nito, bibilangin lang natin dun sa object or dun sa situation kung ilan yung magkakamuka at yung ilalagay natin sa ilalim. For example, para mas maintindihan natin, example number 9, how many arrangements can be done from the words engineering and probability? Okay, so paano gagawin dyan? So for engineering, letter A, and this is letter B. For A, ilan ang total number ng letters sa engineering? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, n is equal to 11. P now is equal to 11 factorial ang ilalagay natin sa taas over kung ilan sila lahat yung nasa ilalim. So, let's start with letter N. Ilan ba yung N natin? We have 3. Yung E natin, 3 din. Yung G natin, dalawa. Yung I natin, dalawa, and yung R natin ay isa lang. Ilalagay natin yan lahat sa ilalim. So, we have 4n, 3 factorial times 3 factorial times 2 factorial times 2 factorial yung sa I. And lastly, we have for R, 1 factorial. So, permutation is equal to 277,200 ways or arrangements. So, ayan. Yung arrangement na yan, yung 277,200 ways na yan, ay yung arrangement na pwede natin magawa from the word engineering. And next, for letter B, sa probability naman, ganun lang ulit ang gagawin natin. Bilangin lang natin. We have a total letters for probability na 11 din. This is P is equal to 11 factorial over yung P natin is isa lang, yung R natin isa lang din, yung O is isa lang din, yung B dalawa, yung A natin isa lang, I natin is dalawa, L is isa lang, yung T and Y natin is tig-isa lang din. So, ilalagay natin yan lahat. Or, sa ibang problems, ang ginagawa na lang nila dito, since napakadaming 1 nito 1, 2, 3, 4, 5, 6, 7, 7 1 nito. Ngayon, pwede na natin hindi ilagay sa ilalim para makabawas tayo ng pagsusulat or sa pagkakalculate. Pwedeng ilagay na lang natin is yung dalawang may 2 or more. Parang ganon. Ito yon, yung B at saka yung I. This is 2 factorial times 2 factorial. Same answer lang makukuha natin kahit ilagay natin yung mga 1. 9,979,200 ways. Same with letter A sa engineering na word natin. Kahit tanggalin natin itong isang 1, yan pa rin yung makukuha natin na answer. Example number 10, for permutation of similar objects pa din, problem, an operating room needs to schedule 5 brain surgeries, 4 heart surgeries, and 2 lung surgeries in a day. How many number of possible sequences of the surgeries? So, permutation of similar objects pa rin ito. So, paano gagawin natin dyan? Meron tayong identical objects. So, parang permutation of similar objects or permutation of identical objects. Pareho lang yun. So, this is 5 na magkakamukhang brain surgeries, 4 and 2 na lang surgeries. Bilangin lang natin kung ilang lahat sa surgeries na yan. We have 5 plus 4 plus 2, 11 ulit. P is equal to 11 over, this is 5 factorial times 4 factorial times 2 factorial. This is now equal to 6,930 na sequences for example number 10. Ayan. Na ma-arrange nila yung surgeries na yan in a day. So, that's example number 10. And for the last type of permutation, we have number 4. If n objects are arranged in a circle, the number of permutation is, itong permutation na to, tinatawag din natin as a circular permutation. And we have the formula, permutation is equal to n minus 1 quantity factorial lang. For example number 11, for circular permutation, how many arrangements can 7 heads be put together to form a bracelet? Circular permutation. So, gagawin lang natin, P is equal to, ang n natin of course ay 7, 7 minus 1 quantity factorial, and we have 720 arrangements or ways. So, ganyan lang ang circular permutation. And that's all for this video, guys. Please like and share. Thank you for watching and see you on the next video.